Hello, everyone. Welcome to Rational Science, the only site on the internet that does physics. Everybody else does mathematical descriptions, and physics is about explanations. It's about explaining mechanisms, especially those invisible mechanisms that we have yet to identify. Okay, but first we are going to start with subject matter which I love, which is the subject matter known as extinction. Extinction of man. Are we going to become extinct? Are we going to end up extinct as a species, right? And I'm saying not only that we will, but very soon indeed. Anyways, questions that people ask and subject matter related to extinction, uh, headlines in the news, etc. That's what I covered in the first half of the lecture. Okay, so we're going to start with you've heard of Omicron, you heard of the latest COVID strand, variant. Well, the other strains like the alpha, beta, delta, all those are gone. Those are in the past. Now we have the Omicron, okay? And supposedly everybody's guarding against them for the winter, okay, in the northern hemisphere especially. And here what you find is says vaccines against Omicron, the bottom line. This comes from the top people in the United States, right? The Omicron variant compromises the effects of two-dose mRNA vaccine-induced antibodies and reduces overall vaccine protection. But considerable protection against severe disease is maintained. In other words, the vaccine they gave you, if you got the vaccine, allegedly covers you even for the Omicron, right? But they suggest that you get a third doses, the booster. Okay, so they say our boosted vaccine regimens work against Omicron. No need for a variant-specific booster at this time. Not yet. They haven't invented the one that attacks the Omicron, right? And and here you have one situation that I looked up this week, and it's all the enemies of the United States. What do they have to say about Omicron? Okay, and these are the main enemies, right? So what do they say? Well, here they are individually. Okay, here we have especially Iran, Russia, North Korea, and Cuba, right? And this is the Russians. Let me get this one out of here. Here we have the Russians, and they say they have detected Omicron variant in 16 people who came from South Africa. Okay, and the Moscow Times, right, says that the Sputnik 5 robust against Omicron it claims that the Sputnik 5 is robust against the Omicron. And so they say, again, no need to take a booster of a new kind of vaccine because the one they have already takes care of that problem, right? The Omicron variant. And here you have the Cubans, and they have a similar situation. They found first case a few days ago, and then more recently, a few days later, in fact, a couple days ago, they detected 4 more cases of the Omicron in Cuba, right? And says that Cuba aspires to have a vaccine ready against the Omicron variant. So we got a little bit of a contradiction. We have one country, a couple countries, Russia and the United States, they say no need to invent a new vaccine. The old vaccine works against Omicron. And here the Cubans are trying to develop a new vaccine, or a vaccine, right, that attacks the Omicron variant. Isn't that a little suspicious? Haven't the Cubans found out that the old vaccine works against the Omicron? Are they the only ones who don't know about it? And here you have Iran, another country that you could say is an enemy of the United States, says Iran minister says new coronavirus strain Omicron could spread. Iran health minister has warned about the possibility, okay, not the certainty, but the possibility of the new coronavirus variant Omicron spreading in the country, but did not announce any travel bans. Okay, so they're not raising any flags yet. They're just saying, well, there's this new variant, and we're aware of it. We're on the lookout, but we're not going to stop the country. Okay, and it says looms, but Iran has no means of detecting it. Well, I guess if the old vaccine works on Omicron, why do you need to even detect it, right? I mean, you would think that if you get like I did, the two shots, right? Hopefully I'm protected against the Omicron as well, because they say that the vaccine they gave me works against the Omicron variant as well. Okay, so I don't know. We're looking at seems like some contradictions out there. That's what it seems like to me. Okay. Okay, and what about North Korea? Well, here we have them. And they say, they warn against the Omicron variant, right? But they haven't found any cases yet in North Korea. And here they're raising flags all over the place, here in Germany at least. It's unbelievable. They've already put all these rules that you need to have a third shot, and that if you don't have the two shots, they're going to require a COVID test, like a daily one, like if you're stopped on the street by the Gestapo. And so here's a big deal. And apparently in other countries, they had what, 1 or 2 cases, 16 cases? Are we going to stop the world because we had 1 or 2 or 3 or 4 cases? And so, the question is whether this is real or not anymore. For me, it's starting to become like an excuse because the politicians can't fix the economy. They said, well, we can't fix it because of the Omicron. And the reason we had to shut down all the hotels, all the restaurants, all the barber shops, all the nightclubs is because this bug is out there. And it turns out, it kills or it hasn't killed anyone apparently yet. But there's been like a few cases, a handful of cases, maybe 1, 20, something like that. So the question is, should we stop the world because there's this bug out there? And the reason I'm asking that also is because there's another issue, and that's that it's winter season, and lots of people go out there and get their flu shots. Remember the flu? This was a bug that we paid attention to for so many years, and now nobody even mentions the flu. Isn't anybody getting sick because of the regular colds or flus? This is the season, And so, it's like we forgot about the flu, or maybe we're mistaking this COVID thing for the flu and vice versa. The question is, what happened to the flu? Has the COVID displaced the flu? Is that what's happened? One bug replaced the other? Like, the killer bees replacing the bumblebee or something like that? I don't know. It does make you stop and think what's going on, right? So I can't blame the people who are conspiracists, as they're known. I sympathize with them here, because it's not very clear what's going on, okay? At least to me. Okay, so here we go with this fellow. He says, we were talking about COVID, and he said that COVID is a fake, just like HIV/AIDS was a fake. And he says, well, you had hardcore drugs and malnutrition. Those were confused, or those created the situation where people got sick. And I guess he's saying that somehow had something to do with the fact that HIV/AIDS spread, right? Okay. He said also that there's a drug that was applied to, or that People got to see if they could be cured of AIDS, and I guess it just made them worse or killed them or whatever. Yeah, these are theories, and again, different people have different theories out there about all these diseases, not only COVID, but AIDS and so on, these modern day diseases. In the case of AIDS, as far as I'm concerned, the HIV, they got it from the jungle somewhere. I guess someone slept with a gorilla or something out there and brought it into civilization. The question now comes with this other bug, the COVID. Where did that one come from? I mean, allegedly it started in China. It started in a city, right? So we're not talking about someone going into the jungle, an unexplored area, and somehow came in contact with a new disease. Here we're talking about a city, Wuhan, right? And that bug was just all of a sudden just popped into existence out of nowhere. It's kind of weird. You would think that if we come across a disease, it would be something that no one has encountered before because it's isolated from humans, from the majority, from the human population. But people have been living in Wuhan for a long time now, and we just caught it now. It just popped into existence out of nowhere. Things that make you stop and think, what's going on? Again, we got to try to reason this out because the information that's out there is a little confusing and contradictory. Okay, and so it's up to you to imagine what's really going on. Okay, and we have another issue. If I can get it there. We talked about brain sizes and intelligence, if there's a correlation. And there was an article that says rocket scientists and brain surgeons are not necessarily smarter than the rest of us, the study finds. Okay, so they did a test on several people, several thousands of people of Britons, right? They compared them against 329 aerospace engineers, 72 neurosurgeons, and they said there's no significant difference in the general population and these guys as far as how smart they are. The conclusion said there was no significant difference in how aerospace engineers scored versus the general UK population. Neurosurgeons only showed faster problem solving and slower memory recall. So, we always talk about the rocket scientists. Maybe not. Maybe these guys are no different than you. Okay. Again, opinion maybe in the end, but here there's a study, right, that says there is no difference in, if we're going to talk about intelligence, like if that test measures intelligence, which is a separate issue, well, then there is no significant difference in the intelligence or smartness of, these so-called rocket scientists, neurosurgeons, and the average population. Okay? In other words, those rocket scientists, they're human. Okay, so here we have another issue with brain and intelligence. Fellow says, dissect the topic on brains and intelligence if you can. Intelligence is such an abstraction that maybe humanity never gets to understand how it physically works on a micro level within its time on Earth before extinction. And another fellow brings up a parallel issue, okay? And let's just go through it so that you see how it's related to this. Okay, he says, by what happens when we die, I'm in fact referring to what happens when you or I die personally. I thought originally his question had to do with the extinction of man and not with personal death. Okay, well, nothing happens. That's it. That's what I answer. He says, sounds like an irrational answer. You're just conjuring an image of a black background. I believe that one can only be conscious, therefore when we die we either relive life from the beginning, okay, I don't know about that, without memory, or are conscious as something else. Okay, so what, we come back from the dead, or there's a soul that survives? Is that what we're saying here? Of course, I have trouble defining what consciousness is. I would say that it is just sensing. Okay, so we have these questions. What are we talking about? Are we talking about um, mind, spirit, soul, all these words that we use to define consciousness or thinking or whatever you want to call it. We've got all these variants of what thinking is. And people have for hundreds of years believed that um, there's this thing called spirit, soul, mind, consciousness that somehow is separate from the body. It's been discussed ad nauseum throughout the ages. Is there such a thing? Is there such a standalone object thing known as consciousness? And all I can give you is my humble version, and that's that consciousness is a verb. There's no such thing as consciousness. And people who confuse consciousness for this spirit, this ghost that leaves the body. Some people say that you weigh more with a ghost in than when the ghost leaves you. They say now you weigh less. Even assuming that were the case, are we saying that that ghost not only has shape but has weight, mass? What's it made out of? Atoms? I mean, I mean, these people are the Dark Ages. That's what it is. Okay, so let's find out. Let's go into this thingy we call mind, thought, spirit, whatever word you want to put in there. Okay, and I start with this. This is what you're seeing here is areas of the brain. Okay, and in this case, it's got to do with love, which is one of the ones that has been studied. And these are neurons, and these are different parts of the brain that they've found are activated when a person has this thingy we call love, okay, this attraction. And there are different kinds of love. There's maternal love, there's sexual love, etc. But this just to show you how the brain works. In other words, these things apparently are turning on, and they were able to map the brain to some degree and say, look, these are the regions that of the brain that turn on and off when someone experiences this thingy we call love. Okay, and here's what happens with these neurons. Let me show you this. Especially the synapse. Okay, and it's you have all these neurons. They're cells essentially, and there are gaps between them that we can't see anything in there. And the question, and they still communicate through that gap, through that separation there. And you know, assuming it's some electrical signal or maybe magnetic signal, of course we would not see it if, especially if it's magnetic, right? There would be nothing there for us to see. The question is whether are we going to simulate this or mimic it, you know, with the proposal by quantum mechanics, which are little electrons that flow across that gap, or you could say it's magnetism, whatever they want to put in there. Or are we going to simulate it with the rope model where you have something physical that you can't see or touch? Okay, so the question is, what's in that region, okay, between the neurons? And I think this gives us an idea of how the brain works. You know, when they pinch your toe with a little needle, okay, you feel it immediately. So where do you feel it? And you say, well, I felt it in my toe because that's where they pinched me. But see, when you see or when you find a quadriplegic person who can't, you know, has his neck, anything below the neck is paralyzed, he can't feel anything there, can't move anything, you can pinch his toe and he doesn't feel it. And you say, well, I thought it was locally, I thought you felt it there, but here you pinch this guy, he doesn't feel it. Not only he cannot move anything, but he cannot feel it. meaning that what has been severed is the connection between that little area of his toe and his brain. Okay, so something there was cut off, usually something in the back of the neck or depending on the injury, right? And so, he doesn't feel it. And he doesn't feel it because his head somehow is disconnected internally from that region of the toe. Okay? And so this gives us an idea that, we're all connected all the way from the head to the toe. If you cut off something which is internal, that connects those things, physical connection, well then now you can't feel the toe. And yet all those nerves are connected, when you do feel the pinch, all those are connected by neurons that are separated from each other by these synapses. And so the question is there a disconnect between two cells, two neurons? Or are they connected physically, but we can't see what connects them? Okay? Is there maybe magnetism flowing in that region? Is it some kind of chemical, or is it electricity, right? And that's gives us an idea of maybe how the brain works. I'm saying a lot of this is electromagnetic, and when we look at electromagnetic, we're going to look at what we're seeing today, and that's that we're looking at torsion, in situ torsion. Like when a road turns in situ, right? Nothing's really moving in the opposite directions here of the rope. Now it's twirling in place, and the ends, by twirling the end, that's causing already a thump, some kind of influence over the atom that's at the other end. And when you look at it from that point of view, nothing needs to travel at the speed of light from your toe to your head. There is no, little electron ball that goes from your toe to your head. It's a torsion that's in situ. And the only reason, a quadriplegic can't feel it is because that physical connection is severed. And you can also look at it as a series, assuming we're talking about electricity. Again, it's merged shells or membranes that twirl in place. And there's a connection all the way from your toe all the way to your head. And if you cut that physical connection, if now they're separated, right, atom from atom or molecule from molecule, cell from cell, right, now you get a gap there. Now there is no continuity. Okay, so keep that in mind. That's what I think electricity is. We're going to look at that a little bit today. Okay, we're going to look at now the, governments. Paul says, anyone who thinks that elites aren't in control should try and take control of any of the world's natural resources and see what happens, or try to start your own utility company, or claim ownership for air rights around some airports, build your own dam, and we are now, have always been, forever will be slaves to the elite. Okay, thinking otherwise is a clear sign of one's delusion. Okay, another fellow says almost the opposite. He says, not that he's wrong, but he says we should have authoritarianism. He says, if the Soviet Union had won the Cold War, we might not have been in an harboring extinction crisis now. The state would have controlled the means of production. Food and important machines would have been produced for the people, and shitty technology would have been made them do it themselves. What I mean is that the economy would not progressively become based on superfluous things such as distraction, knowledge, and services. And people could fall back on the state when the economy collapses. An authoritarian state might also give people great purposes. Perhaps we could far out from the earth and colonize the solar system. Yeah, I don't think so. At least I can only give you my 5 cents worth on that. I'm saying, first of all, let's make sure we cannot conquer the solar system, okay? Um, we're never going to colonize it, terraform it, or anything like that, like Carl Sagan suggested once. It's never going to happen. We might, the best we can probably achieve, which I doubt anyways, but it could happen, because I think we have the technology to do so, is, we could visit Mars. We could send a group of uh, astronauts all the way to Mars, and I think we have the technology to, or close to it, to achieve that goal. But even, like colonizing Mars, like putting something up there and saying, okay, we're gonna live there, no, never gonna happen. Obviously not. Same for the moon. We might visit the moon, but are we gonna put some stations on the moon and live on the moon? Absolutely not. Never gonna happen. And one of the things that you have to think about is that even if we were to achieve that, even if we were to put a colony on the moon or on Mars, and like the guy in the movie, plant potatoes out there, um, so what? What have we achieved? In other words, are we going to expand throughout the solar system? And let's even concede that, okay? So we colonize everything up to Pluto that is inhabitable, right? Then what? Where do we go from there? Are we going to make it to the nearest star, 4.3 million light years away? I'm sorry, 4.3 light years away. You're talking about a long distance there. And the question is, are we ever going to go to the nearest star? And the answer is obviously not. Okay, it's never going to happen. So even if we were to colonize the entire solar system, so what? The Earth is probably the biggest planet that is inhabitable. In fact, I think it is. And Venus is close by there. But even if we terraform those, are we going to populate, in other words, double our population by going to these other stones? Instead of 8 billion or 9 billion people, we're going to be 18 billion because we're spread out throughout the solar system, 18 billion or more, right? No, it's never going to happen. Partly because, we've already exhausted our genetic diversity here on Earth. That's one issue. The other one is that, we stop having children. So there's no incentive, no pressure to leave the Earth. I mean, if we were overflowing and people were falling off the Earth because the Earth is so populated, yeah. But, we're so far away. The Earth is still an empty land. There's a lot of places we could inhabit right now. In Russia's an empty country. Argentina, empty country. All these are empty countries. And people don't understand that. They say, oh, the world is overpopulated. No. At least as far as space is concerned, we got a lot of space out there. I don't know if we have enough resources for people. That's a separate issue. I'm saying that we have space. Space is not a scarce resource as of today. Okay, we could probably fit 1 trillion people on the Earth. I'm talking only about space, not talking about resources. Okay, space-wise, we can fit a lot more people than we have today. Okay, so space we have, but we're not filling that space because we don't have children. We're not having children anymore. Okay, women stopped having children, and so yes, that's going to come to a stop. And so, do we need to have? Is there any pressure for us to go to Mars or to Venus or whatever? Absolutely not. We're not going to go out there. Right now, all those are projects. Lab projects to say, hey, it'd be nice to see if we can develop the technology and the know-how how to get there. Yeah, that's great. Don't tell me we're going to live there. Absolutely not. There's, you got to get that off your head. See, I used to believe all that stuff once myself. I thought, we were going to go out into space, into other planets, conquer not only the solar system, but other star systems, and move on to the galaxy. No way it's gonna ever happen. Okay, that's my 5 cents worth on that. Okay, here we go. First it says, the reason free market has worked so well is because its foundation is self-interest. Now that's a little more rational than the other two fellows, okay? And economy is literally all of us, rich and poor, taking care of our self-interest. Yeah, and that's the Adam Smith philosophy, you know, everybody taking care of themselves moves progress forward. Yeah, that's the way it all works. So, you know, people have different ideas about what government should be. Some people believe, like this other fellow, that it should be authoritarian somehow, that you need to put some kind of order and it's got to come from above, because if you let the masses rule or whatever, it's not going to happen. You got to impose order on the people below, impose the laws, so to speak. Other people say, oh, I'm being crushed by these laws. I don't want them anymore. Who are you to tell me what to do? And so we have all these differences of opinions. But the important one, at least as related to economics, is, you know, self-interest. Absolutely. Okay. Fella says, your conception of human evolution as devolution reminds me much of the creationist view of evolution. Do you align yourself with a creationist view of evolution? Accuses me of being a creationist. I can't believe this. What about religious views on the end of the world, namely the events of Revelation? No, my theory has absolutely nothing to do with the Bible. I mean, I didn't even get the idea from the Bible at all. I got it, in fact, from relativity. Because you have all these mathematicians, and they're saying we're all going to go into outer space. We're going to conquer the solar system, the stars, the galaxy, and maybe other galaxies. That's their idea, because they just imagine this thing evolving forward forever and ever, and they say, oh, so many things we're going to invent in the future. And invention is done with. There are no more inventions. We've invented everything we needed to invent of any relevance. Okay? They changed the color of the car. Well, you can say that's an invention. Yeah. Like one invention out there that came out a couple of years ago was beer. Beer that, was it something about the beer? I can't remember now, but it was a special type of beer. Yeah, beer is beer is beer, and you can change something about that beer. And they call it an invention, you know? No, because the guy who drinks beer is going to drink that beer or another beer. It doesn't matter. And same if you change a blue car for a red car, is that an invention? Well, yeah, I guess you could say that cosmetic change, you can patent it and, you know, copyright it or whatever. Yeah, right now we only make cosmetic changes out there. Manufacturing is dead. Manufacturing is dying before our very eyes. Okay, it's becoming a smaller percentage of GDP and of labor. We're replacing humans with machines to do a lot of that work, and all humans are going into services. So, you know, there's going to be no more inventions. So if you don't hold your breath, this notion that some people have out there that there's going to be this technological singularity where things take off exponentially because suddenly you have these robots doing the inventions for us, and they're going to come up with so many things we cannot even imagine. And yeah, it's like putting it off, like saying, I can't tell you what, because, you know, I'm not one of those robots that's going to be inventing all this stuff. And so they can just imagine that this is going to take off. And no, manufacturing is on its way down, not on its way up. There's going to be no technological singularity. We're at the end of the line. And not only are we not producing people, children, babies, but we're not producing technology either, manufacturing. That's dead as well. So, again, my 5 cents worth on that. Says, what you're saying, what you're arguing for is, oddly enough, a catastrophe which is not as likely to occur as a broad systemic shift. I propose instead that civilization will slowly wither on the vine. Okay, slowly, he says, it's going to be a slow, gradual process, okay, as it adjusts to the decline of fossil fuel resources and deals with crushing birth rates compounded by a gigantic aging population and dysgenic incentive structure. Humanity may or may not go extinct because of, in this gradual process, there will be some organized societies that will attempt to adapt. So he's saying that we can overcome extinction because it's a slow process. It gives us time to think and to fix the problem, whatever the problem is, and someone will survive and restart the race all over again. That's more or less what he's saying here. Okay. Of course, extinction is ultimately about food. Okay, how that came in there, I have no idea because he wasn't talking about food so far. So if there's still food out there, it doesn't really matter whether civilization collapses or not. There will be those who continue. So he's running around in circles. He's saying, yeah, it's about food extinction, but we don't have to worry because there's always going to be some food out there. And as long as there's some food out there, someone will survive and they'll restart the race. This is a notion. This is what he's thinking here. I think that's what will happen to man, a smaller, dinkier civilization that will never rise back to its former glory. What I guess what he's saying is what we're going to be 10 people on the earth and we're going to have this food and it's just not going to rise to the 8 billion people we have today. Is that what we're saying here? What can I say? Let's go with another one because this file says, and this is going to put it in the right context, okay? How long will it take for mankind to fall? Are we talking about years or decades? Will mankind actually go extinct? And so my answer is mankind will go extinct. Mankind has no possibility whatsoever of overcoming extinction, okay? That's what I'm going to argue. Okay, I'm saying we have no way of fixing this problem, no matter what we do. No matter how much intelligence we have, it doesn't matter how much technology we have, it doesn't matter that we can foresee events and react to them. None of that has any bearing on the cause of extinction. And that's why I constantly remind people that they should do Extinction 101 before they do Extinction 102. Everybody's an expert on 102, which is human extinction. And I have yet to find experts on extinction, specifically mass extinction. How did the dinosaurs die? If you cannot tell me that, don't talk to me about humans. You know nothing about extinction and you want to talk about human extinction. Please tell me how the animals in the past died. And that's what science is about. That's what the extinction of man is about. It's not about the future. It's about the past. It has to do with the mechanism of extinction. How did the animals in the past die? How did they become extinct? Once we figure that out, we have to apply that mechanism to man and see if he can overcome it. And yeah, the only one that we cannot overcome is food. Okay? We cannot overcome food because our whole economy is a inverted pyramid scheme. We're always expecting, to be more people in the future so that we sell more products and that keeps our economy going. But that was good primarily for the manufacturing age, which died some 50 years ago now. And it's still applicable to the service age. If you have more people out there, you can provide them with more services. But services is a little easier to provide, like a song, you can provide to millions, and it's just one song, one singer. That's different in manufacturing. If you need to provide 1 million television sets, you need to produce 1 million television sets for 1 million people. So services, like, intangibles, those are a lot easier to spread around, okay, than manufacturing. Manufacturing, goods, tangible goods, you require one per person, whereas the other one, you can have one thingy, whatever it is, one concept, and you can spread it out to 8 billion people without any problem. a song, or whatever it is, specification, how to do something, knowledge, all that stuff, you can spread very easily. You don't have to produce it physically. That's the difference. Anyways, if I ask, how soon are we, uh, or how close are we to extinction? And I've got this graph there that more or less puts it in the right perspective. And again, I want to emphasize that this gives me an idea of when it's going to happen. Okay, and for what, 300, 200,000 years, we were hunter-gatherers, hunters primarily, I'd say. Maybe 10,000 years we were farmers, maybe 200, 300 years we were into industry. We created the industrial revolutions, maybe in the late 18th century, somewhere around there. And about 50 years ago now, we went into services. And perhaps the last 10 years or so, we went into new kinds of services. We went into internet services, okay? And so we're not doing any hands-on services like I discussed the other day, where we have restaurants and hotels that require maids, and restaurants require cooks and busboys and servers and so on. And all those jobs are now being killed, and what are we replacing them with? Well, people are moving into internet. They're doing a lot of internet stuff, which is, just some concept out there, again, that you can spread to millions through the internet. Some hit it big and they say, oh, I'm making a lot of money with this. Great. One guy does it. One guy does hit the jackpot. But the majority of people, they're going to get crumbs out there, and a lot of people just can't enter that business. They're just going to be customers, not providers. And so we're moving people out of the hands-on services now into these abstract services, which are, the internet services. And other people are unemployed. They receive money from the government. Others, maybe sell drugs on the streets or live with their parents. You got all sorts of people out there. And so the question is, we're abandoning now the jobs that this COVID thing is pushing people out of the hands-on jobs, right? And going into these abstract internet jobs, services, programming and so on. That's big still today. And can we live on entertainment alone, on leisure? So that's food for thought for you. Can man live on leisure alone? Someone might even say yes out there. Okay, I'm going to say no. Okay, final issue says, did you go to a rational doctor for your problems, or did you go to a mainstream doctor who relies on past experiments, measurements, accurate predictions, and all the mainstream science you consider nonsense? Oh my God. Poor fellow, the problem here is he doesn't understand the difference between science and technology. All that he mentioned here has to do with technology. When you go to a doctor and he cures you, he's not doing science. Okay, it's not called science. Okay, that's mathematics. Okay, they call it science. When you do an experiment and when you cure someone of something because you gave them a drug, you gave them a massage, you maybe fix his leg somehow. Oh, that's technology. That's not science. Science has nothing to do with someone touching you or giving you a drug or anything like that. Science is that doctor who's in the one corner, maybe at his office, his desk, and he says, now let's see, what causes cancer? That's the scientist. Okay. Now the guy that cures you of cancer, he's not a scientist. Okay. That's mathematics' notion of science. So so this fellow doesn't understand the difference between science and technology, and this technology thingy is what the mathematicians consider science. In fact, the Nobel Prize is given not only to people who come up with theories, in fact, most of them are not given to people who come up with theories. A lot of them are given to people who invent something. You know, I mean, Marconi, for example, he got it for supposedly inventing the telegraph, right? Or having to do with the invention of the telegraph. What's that got to do with science? I mean, is this a medal that they give for science or for technology? What are they giving that medal for? And so it's a mixture. Why? Because the mathematicians consider lab experiments, hands-on experiments, and all these inventions. They considered it as part of science. Okay? No, it's not. We separate science from technology. Science is explanations. You have to explain something. And when I went to the doctor, we had a little bit of both. We had a little bit of science, a little bit of technology. But this fellow mentions has to do with technology. The part that dealt with science is when the doctor gave me her opinion, her theory of what could be wrong. So it could be this, could be that. And these are theories that they don't know for sure. It could be this or it could be that, right? So again, it's what you believe in. They might say, well, I think you have this, and you should take this medicine. Okay, and maybe you take it with a grain of salt. You might say, well, when you go home, you say, well, should I do that? Should I really take that remedy, that drug? And you might decide not to because you're not confident that your doctor really hit it on the nose. Okay, doctor says, I know why you have a headache. You have it because you've been drinking too much beer. Take an aspirin. And maybe you think you have a headache because someone hit you over the head, and then all you need is a pack of ice. so, so we have a differences of technology to address the problem, which has nothing to do with science, which was the theory of why you have some kind of ailment. Okay, so yeah, we have to distinguish science from technology. Okay, let's move on to the subject matter of today. What are we going to talk about today? We're going to talk about voltage. What the hell is voltage? Well, the other day we talked a little bit about electricity, and before that we've been talking about mass and energy, especially another form of mass. Mass is another form of energy, right? And there were some issues that were brought up, and so we need to address those before, as an introduction to the subject matter of today. Okay, so one fellow says, this is what most people use the term physics for. Alpha Phoenix gives a link, says Alpha Phoenix did what most people call physics to verify Derek Muller's claim, because I dealt with Derek Muller's notion of what electricity is. Okay, flow of particles, he says, not really. It's in situ. Something happens there. The electrons move back and forth, from atom to atom. They don't go all the way to the terminal. Okay, what do you call it? Technology, mathematics? Okay, yeah, we got a problem because these people don't understand what physics is about. They don't understand what science is about. That's the issue. And when you go to this Alpha Phoenix guy, you find that. What do you find? You find the same exact thing as what Derek Muller had. In other words, he hasn't changed anything. He hasn't said anything different than Derek Muller. And so he says, the fact that he challenged Derek Muller. No, they said the same thing. They used the same electricity. They said that there's an electron bead, okay, that moves from one atom to the next, to the neighbor. Okay, because this is what they learned at the monastery. Okay, they learned that electricity is the flow of electrons. Whether they flow all the way around, whether they flow only to the next atom, then come back like in alternate current, it's the flow of electron beads from one atom to another, the conduction band, right? That's what's known as electricity in just about everywhere. The Electric Universe believes in that. The John Chappell Society, people who believe in particles and ether and stuff like that. you have the quantum mechanics, string theorists, general relativity. They all, even the classical people who believe in classical mechanics, everybody essentially believes in that the electricity is the flow of electron beads, and and they, in order to come up with that notion, they have to use the quantum atom. And the quantum atom is the planetary atom. So that's why they have this little bead that's going around, right? The nucleus. There's a bowling ball in the center and an electron bead going around. This grain of sand that goes around. The only thing they have to do is draw their model of the atom. We can go with the hydrogen atom. We don't have to have iron or copper or anything more complicated. Just draw for me the hydrogen atom and then explain why, okay, the electron bead doesn't fall to the center where the nucleus is, or why it doesn't spontaneously fly away. If you cannot explain that, you do not have an atom, and your explanation of electricity, the flow of electron beads from atom to atom, is bunk. Okay? And so what Derek Miller did is the same thing as Alpha Phoenix did, is the same thing that everybody else does out there. And they're using the wrong atom. They're using an atom they cannot justify. It's an irrational atom because they don't know why that little bead goes around, any more than anyone can explain to you why Pluto goes around the sun. Okay? What's keeping Pluto bound to the sun? That's what you got to explain. Why doesn't Pluto fly away from the solar system spontaneously? And if you say that there is nothing connecting, physically connecting Pluto with the sun, simply because you can't see it or touch it, then you put a spirit in that same region. You're doing your theory with black magic. You're seeing nothing is in contact between Pluto and the sun, but Pluto doesn't fly away. That's what you're saying. And what you're saying, essentially, whatever theory you have, I don't care, because whatever theory you have, you're using black magic. You're saying it's done without a mediator, without a physical object mediating Pluto with the sun. That's what you're saying. Okay, and that is irrational science. Okay, science, big word there. Just irrational. That's an irrational theory. You have to have a rational theory. In order to have a rational theory, you need a mechanism. In order to have a mechanism, you have to mediate it, you have to simulate it with a physical object. The fact that you can't see or touch it does not make it does not say that there's no object there. There is an object there. We just can't see or touch it, because an object is that which has shape, not that which you can see or touch. Okay, so how do we answer this gentleman here? Well, we answer this way. Don't just follow the herd of buffalo to the edge of the cliff. I mean, the guy says this is what most people, right, believe is physics. Okay, I don't know about most people. We don't care about most people. You don't follow the herd of buffalo to the edge of the cliff. Try to get a brain of your own. Don't use borrowed brains, especially that of the, the scarecrow there. When he went to Oz, he left his old brain there, and he got a new one, I guess, right? That's what the Wiz gave him. So you don't want to use his brain now. Maybe they sell you his brain at a discount or something. Don't take it, okay? You'll have a tough time, though. Independently thinking brains are scarce, okay? So you'll have to shop around. Meanwhile, remember that science is not equal to democracy, authority, or tradition. Okay, so this notion that this fellow has that, the majority of people believe that physics is blah, 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 blah. We don't care what the majority of people think. Okay, we don't go by the majority. This is not democracy. We all vote. It doesn't work that way. Not in science. In science, you got to rationalize it. You got to defend your definition. And so he didn't put a definition for physics, but he suggests that the notion of physics is what this guy did, which is criticize Derek Muller. First of all, criticism is not science. Explanation is science. That's the first one. And the second one is that this guy proposed the same thing as Derek Muller. which is the planetary model, and that electricity consists of the flow of beads, electron beads. Okay, so no, this fellow has said nothing new. Okay, here we have something new, something different, but this fellow, he's got the same thing as everybody else. Okay, another fellow talking about being parrots here, right? You know, just mimicking what the authorities and the superiors told them. Says electrical energy is one of about 25 types of energy. Okay, a form of energy that results from the flow of what? Charged particles. What are those particles? The electron beads, right? And their charge means they have 1.6 times 10 to the minus 19 coulombs each, right? A quantity it carries, the electron carries with it. Energy is defined as a catch-all what? Capacity. Capacity to do work. So what is energy? It's capacity, whatever that is, okay? There's no physical standalone object called capacity as far as I know, okay? But if you find one, please draw it, bring it to the conference, okay? A battery is a form of stored electrical potential energy. We're going to be looking at the battery today, so it's a good introduction to the subject. It has potential energy, potential capacity. What does that mean? Potential capacity, okay. Charge is charged, like in charged particles, is a property of matter. Okay, so there is no physical object called charge. You can't say you're going to move the charge, right? Because he's saying it's a property. It's like saying, I'm going to move the color red of the, you know, the sweater. Sweater is red, or it's big. You can't move big. You can't move red. You got to move the sweater, right? So we have to distinguish the property of the sweater from the sweater. Okay, let's make sure we understand that. Okay, just like mass, volume or density, it is measurable. Yeah, measurable, yeah, it's like saying I can measure color by, you know, maybe in the case of red, you can have 610 nanometer wavelength. Okay, so you measured it, 610 nanometers. Great, and we measure, so, but he said it's the flow of charged particles. And other people just say it's flow of charges. Okay. A charged battery has higher mass than it does discharge when placed on scales. So why does it weigh differently? That's what you got to explain. So to say that a charged battery weighs more, what are you saying? Its soul, its spirit weighs something, when you know, you can pull that spirit out and say, here's the charge, here's the spirit. See, these people go back and forth between treating charge as a mathematical concept and as a standalone physical object. And they get confused. They equate them duality, right? And they get away with it and they don't even realize it. They're not smart enough to figure this stuff out. Okay, so let's kill that parrot there, who all they do is just parrot the official words out there, whatever they learn at the monastery. Let's kill the parrot. Okay, if a battery weighs more when it is charged, does that make charge a physical object? If charge is a property of matter like color or size, does that make charge a physical object? If electrical energy results from the flow of charged so-called particles, does that make charge a physical object? And if energy is the capacity and a battery stores this capacity, right, is energy a physical object? I mean, what are you storing? I mean, it's not like storing beer in your fridge, right? Can you see or touch capacity? And if you can't see or touch capacity, hopefully you don't define an object as that which you can see or touch, because then, you know, you would not be able to touch energy or call it a physical object, right? Which is the way he treated it here. Okay, so, yeah, all these people, all they do is just parrot. They just copy and paste stuff. They don't even analyze the stuff that they copy and paste. They just say, this is what I learned at the monastery. This is the catechism I had to memorize. Okay. You know, counting beads on the rosary. Poor people. They should try to get their money back from wherever they studied, because they gypped them. They gave them a piece of paper, worthless piece of paper. They said, you're a PhD. Oh, yeah, so great. But he got one right. He says fields are mathematical representation of interactions. Absolutely, it's a mathematical representation. That's all that a field is. Okay, and here we look it up just in case. Okay, to make sure that everybody understands this. Okay, what is a field? A quantity. Okay, this comes out of the Wikipedia. All of this represented by a number that has a value for each point in space and time. Okay, so what is a number? Well, a number is a mathematical object, they say. Okay, used to count, measure, and label. Okay, great. What is a value? Well, value is any definite mathematical object, again, all these mathematical objects, right? Most often a number. Point, an exact location in the space and has no length, width, or height. So yeah, hopefully a location has no length, width, or height, right? Space and time, what is space and time? Any mathematical model which fuses the 3 dimensions of space and the 1 dimension of time, okay? And then just in case we look at space and time separately, space is the fundamental space. I like that definition, etc., etc., okay? I stopped there because there wasn't any point continuing if space is the fundamental space, right? And time, what is time? The continued sequence of existence and events that occurs in irreversible succession from the past through the present into the future. So you wonder how they can bend time or warp time if this is the definition of time. Okay? What are you warping? You're warping what? Continued sequence of existence? Is that what you're warping? Okay, and so you see what a field is down at the bottom, which is what this fellow said. It's just a representation, mathematical representation. That's all it is, a bunch of numbers. The only condition that you have to keep in mind is the numbers get smaller the farther away they are from ground zero. So if you have gravity, right, it gets weaker the farther away you get from like the center of the earth or from whatever object you're talking about. If you're talking about magnetism, same thing. It gets weaker the farther away you get. Okay, so a field is what? A bunch of numbers, values in space. What do you mean by space? It means that all these numbers are floating in space. Of course, you're not supposed to imagine it like that because it's a mathematical concept. Nothing but. That's what a field is. And a lot of these people don't understand that. The word field was created by Mr. Faraday in the 1830s. And he called a field like magnetic field because he said, you know, there's these lines there that have an effect on visible matter. He couldn't see the field, right? And so he said, well, I'm going to call this a magnetic field. And so people now say, oh, a magnetic field. What is that? Well, if you put a little charge in that field region, right? The field has different strengths at different locations. And so the field became a series of numbers that describe each location that comprises the so-called field. Okay, and that's what a field is. There is no physical standalone object called field. The so-called field is under the rope model is very simple. It's the threads that are sweeping around in that region. Now you have a physical object, they're threads, and you can't see or touch them. Okay, but we're not talking about values. Mathematics just talks about the value that a charge would have, in other words, what acceleration, what force, etc., what energy you impart on a charged particle that is found within the field. That's how the field is interpreted. In other words, it's a mathematical concept. And it's a mathematical concept made of many mathematical numbers, which is just a value for each point in space. And you can't turn that into an object and say, oh, the field is a physical object. No, the object are the threads that are sweeping around that form this so-called field, the region where a particle is influenced. Okay, so physics is about objects, not about math, about numbers. Okay, continuing here. Any thoughts on why an electrical circuit has to be closed? And when this guy asked this question, I had no choice but to answer it, and that was the subject matter of today. So this is the question we're going to try to answer, okay? Why do we have to close that circuit? Okay? Why can't we leave it open and have, you know, all the electricity fly through the air? Very important question because, you know, according to quantum mechanics, electricity, they got rid of the atom. they don't even need the atom anymore. Now it's just a flow of electrons. So all the electron beads, like, bullets, flow through space, and that's called electricity. So there should be no reason for the electrons to jump the gap there and reach the other side. Okay? Why not? Why don't they? Why don't they just jump across in space, especially? You have this circuit in space. There's nothing there. Well, not in quantum. Even the false vacuum is made of stuff, right? But I mean, in rational science, you got empty space there. We don't need to put the word empty because space is that which doesn't have shape. And so the question is, will the electrons jump across from one point to the other across that gap? Okay, and if not, why do we have to close it? Why do we have to close the circuit, make a closed circuit, closed loop circuit? Okay, very important question, right? Because this is the one that leads us to an understanding of electricity. Okay, here we have a DC circuit, and we talked about that the other day, which is what this fellow is saying. If you close the circuit, you have all these electrons flowing, direct current, right? AC, alternating current, a little different, looks more like this. Showed this the other day, and it just goes back and forth because you're changing the polarities constantly, okay, somehow. And so the question is, which one is electricity? Does electricity have to go all around, or does electricity just move back and forth? Okay, but the point here is that in AC, at least, right, it's a local phenomenon. If you put a lamp there where that resistor is on the right side there, well, then it's going to turn on. Okay, so the question is, how do those electrons produce this light? Why does the light turn on when those electrons are moving back and forth between atoms? Okay. Okay. So let's move on here. This is what it looks like in a vacuum chamber. Okay, important to see this as well. Okay, and there you see the atoms, and essentially this is the notion they have. Electron beads just moving from atom to atom, from one plate to another, from cathode to anode. Okay, so this is their notion. We compared it against the one that we propose instead, which is this. We're saying that actually electricity is the bunch of merged electron shells that are spinning in situ. Okay. Okay, and so now we get to voltage and find out why that had to be connected. Okay, and we start with a definition of voltage. First, we need to know what this voltage is, because it's voltage that triggers whether you use my version, which is the merged electron shells that are spinning in situ, or you use the bead model where the electron bead goes from atom to atom. You need to have this thingy trigger it, which is known as voltage. And what the hell is voltage? Okay, and it's got something to do with positive and negative. Okay, and here you have definition. It says voltage, potential difference or electric pressure, is the difference in electric potential between 2 points. Okay, so it's some kind of pressures, some potential difference, whatever that is. Right now we don't know, but this is the definition. Okay, so we have 2 points, and there's a difference in potential, or there's pressure from one point to the other. Okay, pressure we all understand, right? You push the box, that's called pressure. Pressure is push. Okay. On the other hand, potential difference, well, usually it's the notion that we have of gravity. Like if you're on the mountain and you jump, hopefully with a parachute or something, right? You fall downwards. Okay. Why? Because there's a potential difference. They call that a potential. Why, we don't know, because again, with the word potential, we're not identifying the invisible object that's pulling on you or pushing on you. All we're doing is saying there is a potential difference. That's just mathematics, and that's just a description. Okay, so let's distinguish that from explanation, which is what caused you to fall downwards. Why did you fall to the sky? Okay, that's the issue that we're trying to resolve here. It says voltage is defined so that negatively charged objects are pulled towards higher voltages, while positively charged objects are pulled towards lower voltages. So we have this potential difference, okay? And so they're just introducing this notion of positive and negative. And you say, well, what does that mean in physical terms? What is this positive and negative? And it turns out that they never defined it. They have no idea what positive and negative is. They could have said it's A and Z, just like they say north and south, right? They could have said east and west. I mean, what is this positive, negative? What does it mean from a physical standpoint, okay? And, we always say, well, the positive side of the magnet attracts the negative side. Yeah, you could say A attracts B, red attracts blue. You could have said many things. What's the difference between positive and negative? Okay, that's what we need to figure out. Otherwise, all you did was just a description. You still don't understand how a magnet works. Okay, and so here we have the notion that they have of voltage. Okay, and it's this notion of water. They say this is a difference in potential. So they have the positive on the top, negative on the bottom. It could be the other way around depending on what particle is it the positive particle that's moving towards the other side? Okay, so keep that in mind. They have no idea, so this is arbitrary that you can put a positive on the high one and the negative on the low one. It could be the other way around, okay? In fact, the next thing shows it here, okay? Is that what we're saying? We're saying that we have something that is higher than the other. Is that why the electron beads roll downwards to the one on the bottom? Is that the analogy? Let me show that again, okay, side by side. I mean, what they're saying, and again, don't worry about the signs because again, they say that the positive could go to the negative or vice versa. So the signs are really unimportant in that sense in what I'm showing here. The important here is that they're saying it's a difference in potential. That's what I'm showing here. So a difference in potential, we can all understand the analogy of the water flowing downwards because it's gravity, whatever gravity is. Okay, we're not concerned about that right now. We're just saying there's a difference in potential because of gravity, because water tends to go down. So they use this as an analogy for voltage. Are we saying that the electron beads, which is what is rolling in this case, right, which is what's going from one atom to another, are we saying that the electron beads are flowing downwards because one of the terminals is higher than the other? Can we switch them around and find out if the electron beads flow in the other direction? Can we lift the positive in this case, in this example, higher than the negative, and now the electron beads will flow in the other direction? Because if this is not the case, then the analogy, the water analogy, is irrelevant. It has nothing to do with what electricity is. So the analogy is wrong. But this is the analogy 99% of the people out there use to explain voltage. They say it's just a difference in potential. Well, what do you mean a difference in potential? We understand the water one. How does that work with electricity? Are the electron beads rolling down an inclined plane? That's the question. Okay, let's get rid of these. Okay, so you see where I'm going with all this. If this is voltage and it's a difference in potential, are the beads rolling downwards on an inclined plane? Well, very easy. We could just put one terminal in the higher than the other, and will the electron beads flow in the opposite direction? Well, I don't think so. Okay, so the analogy is worthless because we haven't understood anything. All we understood is that the word potential, and potential is a mathematical term. It has nothing to do with physics. Okay, so potential, no go. Okay, so here's the quantum mechanics version of a battery, a lead battery. I'm going to go with the simplest of all. I'm not going to cover all the possibilities, the hundreds of possibilities that there are for generating current and voltage and so on. I'm going to look at this, which is the lead battery, lead acid battery, which is the first battery that was invented, I think. And so the issue here is why do those beads the electron beads go around. You can see the red ones there. Those are supposedly the electron beads are going around in the circuit. Okay, what causes them to go around? Okay, and for that you need to look at the chemistry of this. Okay, so let's move to the chemistry. Here you have it. Okay, you have the electron beads flowing, but what's happening? What's triggering that? Well, you have the one side, one battery is lead, and the other one is lead dioxide. Okay, and what happens? There's a chemical reaction with the sulfuric acid. That's diluted sulfuric acid. Okay, that's that bath there, and there you have the chemical reactions. Okay, and you create these hydrogen ions. Okay, and what happens is that they say when those chemical reactions take place, the beads move around. The electron beads move around from one terminal to the other. Okay, so you need that chemical reaction, and you can see that it's a closed system. The question is whether that reaction would stay in place, would remain, if you break that circuit. Okay, and the issue here is that you have to be aware of is the following, that there's a reaction between the sulfuric acid there and the lead. Okay, but there's a chemical reaction that you can have. It's just, if you just pour sulfuric acid on lead, there will be a certain reaction there, but that doesn't cause electricity per se. In order for you to have electricity, you need to connect that wire, okay, around the green wire, all around, and there has to be a closed system, because now the electron beads flow and they stimulate the reaction between the sulfuric acid and the lead terminals. Okay, so that's what you have to keep in mind. Okay, the reaction is stimulated by the electricity. Otherwise, you would not have that flow of, in other words, it speeds up the reaction. That's the point. Otherwise, you would have just a chemical reaction between the acid and one lead terminal, which is a very slow process. Okay, the electricity is what speeds it all up. Okay, and so one thing you have to keep in mind is that that is really a what you're seeing there, the electron beads moving straight forward. That's not really how it's done, but that's how it's always illustrated. Let's illustrate it a little more like it is. Okay, and here it is. They jiggle around, they kind of spiral around. The electron beads are known to spiral around the wire as they move. So this notion here that you see here, this one is wrong. Okay, it's not straightforward from atom to atom. For some reason, okay, for some reason, they do this. They move around like oscillating. They spiral around the wire. Okay, and this is very important to understand that. Okay. And it's already been, shown through many observations, many experiments in the past, that this is the case, that these things go around. It's like a fact. So we don't need to, if you have doubts about it, go to a lab and do your experiment and convince yourself of it. This is something that is already well known. It's a fact. It's like saying that the earth is round and you're saying, no, the earth is flat. Yeah, if you want to buck the trend and say it's flat, fine, you're a flat earther, great. No, the earth is round and spherical, okay? And that's why gravity works. Otherwise, gravity wouldn't work. And likewise, the fact that the electrons spiral around has already been shown, ad nauseum. And here you see, it's known as Fleming's rule, really, but here you see AC going back and forth, okay? And the question is, this AC, it doesn't flow all the way. It's like it's not only spiraling, okay, so these two things have to be put together. Not only are the electrons spiraling, but they're not moving all the way to the terminal. They're what was his name? Derek Muller suggested, and which is shown by the AC, that the electron doesn't move very much. It drifts very little. They said it's the field that moves at the speed of light. It's the signal that moves. But the electron moves very little, they say. Okay? So let's see. The electron moves very little and it's spiraling. So more or less it's spiraling in situ. And you have tons of these electrons spiraling in situ, okay? So keep that in mind. This is what we're seeing here. And again, this comes from what is known as Fleming's rule. Okay, here you see it. This fellow, his name was John Fleming. Okay, he was an electrician. He worked for Marconi, beginning of the 20th century. And he came up with the left-hand rule, which is what you see there. Force goes perpendicular to magnetic field, which is perpendicular to current. All three are perpendicular to each other. And there you see it with the light, the electromagnetic wave, okay? You have the electric field one direction, magnetic field 90 degrees to it, okay? And where's the force or where's the energy? Which direction is light traveling? Perpendicular to both. Okay, we got that? Okay, so here we have Fleming's rule applied to electrons, and you can see they're spiraling around. If you find an electron in a magnetic field, okay, what you'll see is that it'll spiral around, okay, because it's moving in one direction while it's going in circles. And so what that does is compel just think of that trajectory, okay? It's not only going around, but going around forward, which is a spiral path. In fact, that's what the people at the Large Hadron Collider say. They accelerate electrons, they accelerate protons. They don't say that the electron moves back and forth. They say, no, we accelerate all around the beamline. What do you mean? I thought that was just moving a little bit, and what you're accelerating is what? The field, the signal, the abstract numbers. And these people say, no, we accelerate the electron beads or the ions. They strip allegedly they strip the electron from a hydrogen atom. They're accelerating the protons. They don't say that the proton moves back and forth. They say they accelerate it all around the beamline. Okay, and here you have the helix. Okay, another version of that same one. It's a helix going inside a wire. Okay. That's what it is. It's a helical motion. It's a spiraling type of motion. Okay, so that's how an electron moves along a wire. Okay, but then again, does it move all the way or does it move just a little bit? Okay, how does it move? Does it move a little bit? Or does it move, in other words, does it move in situ essentially and in circles? Meaning if it moved a little bit forward in circle, it described a helix, a spiral, right? Keep that in mind. That's the motion. So what are these people showing? Well, they're showing something like this. They're saying in a magnetic field, the force is always at right angles to the motion of the electron. Fleming's left-hand rule. And so the resulting path of the electron is circular. And if it's moving forward, it's a spiral. Okay. What are all these people describing? Well, it seems like they're describing a rope turning in place or what I call the serpentine, merged cells, right? That's what it would appear. Okay, let's find out. Here we have the dynamic version of that, okay, just so you can see it. Okay, so in a magnetic field, the electron would behave like that. It's kind of spiraling. And if the electron is moving in some direction, right? For example, in the direction of the arrows there, well then, yeah, it's gonna move like a spiral. It's gonna be a spiraling motion. Okay. Okay. So what are these people describing? What can we conclude from this? Here it is. These are the conclusions. Let me get that. How did that become so big? Give me a second here. Okay, let's get it up here. Okay, so what have these folks been describing all these years? Well, the electron bead spirals. Okay, it spirals more or less in situ. Okay, it doesn't move very far. They say the electron bead moves very little, like from one atom to the next, in a spiraling manner. right? Because it's got to return if it's going to do alternate current. It doesn't go all the way. What travels all the way, what travels at the speed of light is the field, the signal. Okay, we covered that the other day. It doesn't travel all the way to the terminal, and it spirals for no reason. They have no mechanism for why that electron beam spirals or even moves outside the atom to begin with, except this so-called voltage thingy, which we still don't know what it is. It's just a potential difference, you know, between something high and something low, some kind of pressure of what? Of who knows what, because we don't have the what. It just says it's pressure, whatever that is, right? Whatever's causing it. It is surrounded by lines of force, okay? Remember, when the electron moves, it moves in a magnetic field. What is a field? A bunch of lines of force. That's what a field is, a magnetic field, right? Okay, known collectively as a magnetic field. What is the rope model? Merged electron shells swinging threads around. Okay, so we have all these merged shells. Okay, their electrons are made of the same threads as the rope that interconnects them. We have two atoms. Okay, to make it simple, two atoms which are merged one with the other, like I showed the other day in the case of hydrogen gas, H2. It's just two atoms, two merged atoms, a figure 8 atom molecule. And all these are turning around. When they do, they swing around the threads. Okay, some of the threads that either that make up the rope between them or the ones that make up their own bodies. Some of those threads start swinging around. Okay, and so what is this positive, negative? It's clockwise, counterclockwise rotation. From one point of view, you see it as clockwise. And if I do this, well, for you, hopefully this is counterclockwise, right? For me, it's from my vantage point, right? Okay, I'm seeing that my hand is moving clockwise, but from your point of view, hopefully it's going counterclockwise. Okay, and that's what's happening. It's just clockwise, counterclockwise rotation of the whole serpentine, as I call it, extensive rows of electron shells, merged electron shells. And so a circuit must be closed for the entire serpentine to twirl on itself and stimulate the chemical reaction between the sulfuric acid and either the lead or the lead dioxide. Turns it into lead, what is that? Sulfate. So the issue here is the following, that you need that chemical reaction because if you just pour acid, you know, sulfuric acid, you pour it on lead, there's going to be a chemical reaction there. It's a slow, it's like almost if you pour water on iron. Will there be a reaction? Well, yeah, you can have oxidation over time, rust, right? It takes a long time. But if you stimulate it with electricity, that reaction is much faster. And that's what's happening. What you have is the serpentine is twirling all around the circuit. By doing so, it comes back to the other terminal. And now what it's doing is stimulating the reaction. Now the reaction is faster, which stimulates the twirling of the entire serpentine that goes around. And so by going around and twirling fast, it's a self-sustaining system, okay, until you open the circuit. Okay, so that's the notion we want to give you there. Okay, and here is, we're going to illustrate that. Okay, here's the reaction. Here's the bath, and you have the sulfuric in contact with the lead and the lead dioxide, and it's relatively slow. That's what I'm trying to illustrate there. It's a relatively slow process, okay? But what happens when you put the circuit in there, when you connect the terminals? Well, now what you have is, it moves a lot faster, okay? Moves faster, and what it does is trigger the reaction to occur faster, and that's why we have electricity. Now the serpentine that goes, or serpentines, there's many of them, going around, they move a lot faster. Electricity does stimulate the reaction, which in turn stimulates the electricity moving around. Okay, And again, I'm doing this with the lead battery. Okay, I want to make sure that you understand that this is just for the lead battery. Um, there are other scenarios, and people are going to say, Bill, you didn't explain this, you didn't explain that. Yeah, right now I just want people to understand the basics, how it how it works with the lead battery. Okay, very simple. You have a reaction between sulfuric and the metal, and if you just have that reaction and nothing else, no, you've got you got a very slow process, and there is no electricity there. If you want electricity, you got to connect the terminal to the other side, right, through a wire, and that whole thing is now connected, around the wire, and the serpentine now is what triggers the whole reaction to occur. Okay, so you need a closed circuit because of that. Okay, let's get on to the questions and comments people made since last time. A lot of them have to do again with what is an object. And here you have it. It says, your physical objects are made of what physical substance? I could say truthfully that wind is not a substance or object. Good, good. Wind is not a physical object. Wind is a concept. You're right there. It was air moving at high speed that wrecked my house. Yeah, correct. Good. It's air is the physical object known as a gas. Okay. And the objects are really the little oxygen atoms, or you can say even the molecules, fine. But we look at that whole thing, okay, we call air, that gas, and we take it as a single body. So we say it's air that pushed my house down. We can say that air is the object because we're looking at the shape of that whole blob of air. We're not saying, oh, what is it made out of? No, we don't care about that. We're saying we're looking at air as a whole, okay? And it was air that wrecked his house. If there is no wind, hence no force, okay, to feel or measure, must we say air therefore does not exist? Okay, so the guy is confusing a million things here, okay? He's confusing object with exist, okay? And we've had that in the past. Here, let me show you. Where is it? Hume Kant made that mistake. Okay, here they are. Okay, they say Hume said the idea of existence then is the very same with the idea of what we conceive to be existent. Okay, that idea, when conjoined with the idea of any object, makes no addition to it. Whatever we conceive to be existent. And a few years later, Kant said about the same thing. He said, by whatever and by however many predicates I may think of a thing, even in completely determining it, nothing is really added to it if I add that the thing exists. Okay? And so, yeah, this fellow, first of all, confuses thing, object, with exist. Okay? That's the first problem. Okay? He thinks they're synonyms. And that's why he talks about air existing. You know, the issue of existence should not even, the word should not even enter the discussion. We're talking about what a thing is, okay? That's the first one. Wind is not a thing. He said it right at first. Now I don't know why he says if there is no force to push the wind, I guess. Well, what is this force that's pushing the wind? Please draw it. Show me what force is pushing the wind or compelling the wind to blow down your house. Okay, so, but what is the issue? He says, what are your physical roasts made of? And for this, we have to go, here to, let's put over here. It's known as the word idiot, okay? And a rational individual just has ideas. Well, an idiot, right? We put the "ot," making it a big idea, right? And so an individual with big ideas is known as an idiot, okay? And these are typical idiotic statements that people make, okay? When, the first one is, what is the electromagnetic rope made of? Those are the type of questions they ask. What do you mean by shape? Why is there something rather than nothing? It is unscientific to ask what came before the Big Bang. You're not supposed to take the warp space-time canvas analogy literally. Yeah, sure. So how come the Earth doesn't fly out of the solar system, right? It's like asking what's north of the North Pole. These are the type of answers some of these idiots give you, okay? And a quantum particle can be at two places at once, and so on and so forth. These are the type of issues that these people always raise, questions and comments that they make. And so this person is asking, what is rope made out of? Why is this an idiotic question? Okay, here, let's find out. Okay, asking what is a rope made of why is it irrational? Mereology is unscientific. What is mereology? Well, look it up, and then you'll educate yourself. Object, it's not equal what it is made out of. Object is that which has shape. So you cannot ask, what is it made out of? Okay? Then it turns out that, an object, in this case the thread, right, is an elementary or fundamental entity. They're at the bottom, okay? So it's irrational to ask, what is an elementary fundamental entity made out of? And for that, you need to look at what an elementary entity is, okay? So look up elementary entity and you'll find out what it is and why it's an irrational question, okay? To ask, what is an elementary entity made of, okay? Table is not 4 legs and a board. Table is a single piece body you point to, okay? So you cannot say, oh, a table is 4 legs and a board. You can't say that, okay? Table is what you pointed to and named. And so physics outlaws anything which is mereology, which is ether, field, plasma, vortex, dark matter, false vacuum, all that kind of stuff. That's all irrational, because the person who's proposing this is referring to what the thing is made out of, because that's what he's going to use. He's not going to use the field. He's going to use what's inside the field, what affected the charged particle inside the field, for example, or what affected the ether inside the ether. They say, well, the shaking of the ether is what is light, for example. The wave of light, that's the waving of the ether. What is a plasma? Well, again, it's something that happens inside the plasma. It's the motion of an electron inside the atom. The atom spits out an electron, essentially, or gains an electron. That's what a plasma is. So there's motion inside this static object, because they're referring to what plasma is doing about its constituents and not about the plasma itself. Okay. Same with vortex. What is vortex? Well, a tornado is a vortex, and you say, well, is the tornado a single piece object? And no, they're referring to the air that's moving around. So don't talk about the tornado, talk about the air. That's the object, okay? And even with air, you can talk about what the air is made out of. That air is good for, as an object, to talk about tornado, but tornado is not an object. Tornado is a concept. It's swirling air, that's what it is. And so on. What is dark matter? Well, dark matter is all these little particles that make up dark matter, and so on. So all these are referring to what the thing is made of, okay? And that's irrational in science, okay? And the electromagnetic rope is made of 2 threads, okay? That's what it's made of. So I don't know why he asked this question, what is the rope made of? Don't you know? I mean, people should just visit the local hardware store and ask for a rope, and they'll give you something like this, okay? Ask them for a 2-strand rope. That's what I use, okay? And there are ropes that are made of more strands, but ask them for a 2-strand rope, see what they give you, and you'll find out what it's made of. It's made out of 2 strands. How can that be so difficult? Why did you have to ask that question, okay? Yeah, okay, and here all related to objects, right? Say, if you reject see, touch, draw, and imagine, shape doesn't mean anything at all. my poor God, my poor devil. How do you point to an invisible, intangible object without imagining and drawing it? It's simply impossible. The magic rope isn't an invisible, intangible object, but a dynamic concept. Rope is a concept between any 2 atoms. That's why, I put that. The definition of the word object destroys all religion. These people are upset because they have no definition to propose in exchange. They come up with all these irrational questions. I wonder what's going through their minds. Poor people. I mean, and me, I'm the culprit. I do plead guilty. I put these issues there, and it destroys their religion. They say, look, I studied 10 years, I got a PhD, and now you're telling me that everything I learned at the monastery was wrong? Yeah, so they object. They don't like these definitions because it destroys what they believe in. And so they're going to fight them, and they realize this. And so they're going to fight it with everything they've got. Okay, a fellow raises an issue about weight. Says, I disagree with weight being static. Okay. Weight is a concept because we can't point at weight, and it describes the effect of two objects pressing against each other. It does? Is that what weight is? Objects pressing against each other? Weight is not a pull of gravity? Because that's what everybody describes out there. Now this fellow is saying it's pushing. An object pushing on a scale, I guess he's referring to, right? For example, an asteroid in space can't be said to weigh anything, but when it impacts the Earth's surface, then it has weight. And even when moving towards Earth, it only has velocity and no weight, in my opinion. No. Poor fellow. Poor fellow. He's just so disoriented. He doesn't even have his feet on the ground. He doesn't have any idea. Weight is static by definition. Okay, let me repeat that. Weight is static concept by definition. Okay, weight is equal to G, big G, okay, gravitational constant G, mass divided by distance squared. What is that distance? Separating the two masses. It's a static concept by definition. Okay? That's the first thing you have to understand. Second, you're wrong. The astronaut falling through space, he weighs differently at every location without putting him on a scale, okay? Because of the equation. And here's the equation. Let's put it up there so we can talk a little more illustratively. Okay, let's illustrate this. Okay, there we have the astronaut. Okay, he weighs differently at different locations without putting him on the scale. You do not have to weigh the guy. You do not have to push him against the wall to say, oh, he's got weight. He has weight already. The fact that he doesn't feel the weight is irrelevant. The equation tells us that he has weight. Okay, what's the equation? It's Newton's ascribed to Newton, which is again force. In other words, weight equal gravitational constant mass divided by distance squared. Okay, so by definition, weight is static. Okay, it's not that you believe or you don't agree. It's got nothing to do with that at all. You have to accept it whether you like it or not. That's the point. And this person doesn't understand that. It's like saying, black is black. And he says, no, I don't know if I'm going to believe that, Yeah, black is black. I'm sorry. If it's black, we call it black, and you have to accept that that color is called black. And red is another color, and you point to it and say, that's going to be my standard for red. Okay, and so it's by definition, we call that red. Let's assume 600 nanometers, right? We say that's the perfect red. Anything beyond is the light red, and anything in front is going to be dark red. But that's red, okay? And by definition, it's red. Now you can't say, well, I don't know if I believe that. It's red by definition, okay? So I don't know what to tell you. Okay. Move on. Another fellow here says, assuming the rope hypothesis is if every atom is connected to every other atom, would it be rational to assume that all potentially empty space is occupied by the ropes? Thus, there is no such thing as empty space. I don't know how this can be so difficult. Please, people, give me a break. Okay. There's a rope, okay, illustrated, okay. What's the black stuff that serves as backdrop to the rope and ensures that this object is not an infinite block? Because if you don't have matter chiseled by space, so to speak, contoured by space, surrounded by space, then that object would be a single infinite block of whatever. Hopefully, even God, Almighty God, is surrounded by space, is contoured by space. Space serves as his backdrop. Because if that space wasn't there, poor God would be an infinite block of whatever, if you can imagine that. Okay, so no, something has to give shape to things, and all objects are made of space and shape. Okay, all objects. We don't have to specify the word space, because we say shape, and you cannot even conceptualize shape without space. Ultimately, right? In the ultimate case, every object is surrounded by space. Every atom is contoured, is encapsulated, if you want to use those terms, by space. What is space? That which has no shape. How can this be so difficult? Is it? I mean, is it so difficult? My son says it is difficult, and I have trouble believing that. I have trouble accepting that. I'm sorry. For me, this is just second nature. Okay, fella says, what is an atom? I say it is a magnet. Yeah, in a way, it is a magnet, okay, but then we have to figure out what a magnet is, right? An atom is, under the rope model, is a membrane, the electron membrane, that encapsulates a proton. I call it the dandelion because that's what it looks like. Like an urchin, sea urchin, rolled up sea urchin, all these spikes pointing outwards radially. Okay, and so we have the electron membrane encapsulating the proton star. Okay, and so there you see it. That's a cross section of it, and what you see is all those ropes. When the atom vibrates back and forth, it torques those ropes, and that's what we call light. And the aggregate of that light is we call energy, right? That's the energy. And charge is what's happening at the edge, at the surface of the electron shell or electron membrane. What you have is there, you could say, a rubbing, some unimaginable friction when the rope when the rope is released and absorbed, which is when an atom releases energy and absorbs energy under the Bohr model, right? So that releasing and absorbing energy is what you see there. It's releasing and absorbing rope, okay? When it does so, okay, it torques the rope, and when it does so, all that friction going on around the electron membrane, that's what we call charge. That's the charge on the electron, which we measured as 1.6 times 10 to the minus 19 coulombs. Okay, so that's the notion. But then the question is, if that's the atom, how does it become a magnet? You know, and a magnet, you have to imagine these two bar magnets being attracted, and there are fields forming a single field, like you see there. But that's subject matter for Wednesday.